Over the past 2 years, I have made many videos on how retrieval augmented generation has become a standard feature in nearly all AI applications, whether it's intelligent customer service, enterprise knowledge bases, financial analysis, or legal document Q&A. They all use the same logic: document segmentation, vectorization, matching using cosine similarity, and then feeding the retrieved content into a large model for answering. This solution is simple and effective, but the problem is also obvious. When the problem becomes complex, spans multiple pages, or even involves multiple layers of logic, vector similarity retrieval often goes in the wrong direction. For example, you asked, what will be the year-over-year change in the company's cash flow from operating activities in 2023? A traditional RAG might find a bunch of paragraphs containing cash flow but miss out on key context: operating activities versus investing activities, 2023 versus 2022. The result? High similarity, but poor correlation. Many RAGs have used a technology called VectorDB, which converts text into numerical values to search for similar text. Still, the problem is that similar does not necessarily mean desired information. For example, a common problem occurs when a similar paragraph in a manual is hit, but important conditions or exceptions are overlooked. That's where PageIndex comes in. This is a new RAG mechanism devised by Vectify AI, and the idea behind it is very simple. When people read a book, they first look at the table of contents, open the chapter they are looking for, and then follow the subheadings to get to the desired location. PageIndex lets AI do exactly this, allowing you to find truly related parts rather than similar sentences. So let me give you a quick demo of a live chatbot to show you what I mean. I will ask the chatbot a question. What is DeepSeek R10? Feel free to ask any questions you want. If you look at how the chatbot generates the output, you will see that when I input a query, the agent first loads a PDF file, downloads it locally using Python's request module, and saves it to a structured folder. It then submits the PDF to PageIndex, which builds a hierarchical tree structure of the document, organizing it into natural sections and generating summaries for each node. PageIndex is a new reasoning-based, vectorless RAG framework that performs retrieval in 2 steps. First, it generates a tree structure index of documents, and second, it performs reasoning-based retrieval through tree search. Unlike traditional vector-based RAG systems, PageIndex does not require vectors or artificial chunking, simulates human-like navigation through the document, and provides a transparent reasoning-based process instead of approximate semantic search. Next, I prepare a carefully crafted prompt for the large language model that includes my question and the simplified tree with text removed to reduce size, and ask the model to identify the nodes most likely to contain the answer, returning both its reasoning and a list of node IDs in structured JSON. I then create a mapping of all nodes in the document tree, parse the large language model response, and print the model's reasoning for why it selected certain nodes. After that, I loop through the identified node IDs, retrieve their titles, page numbers, and text, and compile this content into a readable context. Definitely stay tuned throughout the end of this video. If you guys haven't followed me, I highly recommend that you do so you can stay up to date with the latest AI news. Lastly, make sure you guys subscribe, turn the notification bell, like this video, and check out previous videos because there is a lot of content that you will definitely benefit from. So that thought, let's get right back into the video. PageIndex works in 3 major steps. While ordinary OCR processes each page, which can lead to disorganized headings and lists, PageIndex's OCR understands the entire document as a single structure and digitizes it neatly while preserving headings and tables. Convert documents directly into a hierarchical structure like a table of contents. A tree structure with chapters, sections, and subsections is created, making it easy to navigate even long reports without getting lost. And the AI searches the tree based on the question and picks up all relevant parts. It also knows which pages and chapters have been visited, so the search results are well-founded. Conventional RAG vectorizes entire documents and stores them in a vector database. It then searches for relevant documents based on the similarity between the user's question and the content of the documents. However, this method relies only on the statistical similarity of words and sentences, so it may not always capture true relevance. Long documents are also broken into chunks, which disrupts context and hides important connections. PageIndex solves these problems by using the inherent hierarchical structure of documents without breaking them down into small pieces. This allows large language model to retrieve information based on contextual semantic relevance rather than simple word similarity. Let us now explore step by step and unravel the answer to how to create a vectorless. We will install the libraries that support the model. For this, we will do a pip install requirements. First, I import the PageIndex client class from the PageIndex package and also bring in some helper functions from PageIndex. Then I generate my own API key, which I copy and paste into the variable PageIndex API key. After that, I create a client instance called PyClient by passing my API key into PageIndex client. And now I'm ready to use this client to interact with the PageIndex API for searching, indexing, or managing documents. Let's import the OpenAI package and set my OpenAI API key to the value I got from the OpenAI dashboard. Then I define an asynchronous function called call.olm that takes a prompt with optional parameters model and temperature. Inside the function, I create a new async OpenAI client using my API key. Next, I call client.chat.completions.create, where I pass in the model name, the conversation messages, and the temperature. Once the response comes back, I take the first choice's message content, strip extra white space, and return it. I import the OS and request modules since I need them to handle file paths and download files. Then I set PDF watch URL to the link of the paper I want to fetch, a PDF from archive. Next, I build a local path called PDF path with the file name extracted from the URL. After that, I sent a GET request to download the PDF using requests.get. Open a new file in write binary mode, and save the content locally. Once the file is saved, I finally use py_client.submit_document to upload the saved PDF into PageIndex, take the returned doc_id, and print it out to confirm the document has been successfully submitted for indexing. After I've submitted the document and received a doc_id, check if the document is ready for retrieval by calling pi_client. Is retrieval ready? If it's ready, I then call pi_client.getTree, which gives me the structured outline of the document, and I extract the result part from the response. Next, I import JSON to handle and format the document tree. I set up my query, here asking, what are the conclusions in this document? To simplify the tree, I removed the full text and kept only titles and summaries using utils.remove fields. I create a search prompt that tells the LLM to identify relevant nodes and return a JSON with thinking and node list. I embed the question and the simplified tree into this prompt. Finally, I call OpenAI to obtain structured JSON that points to the most relevant parts of the document. Later on, I create a lookup table for the tree by calling utils.create_node_mapping, which gives me a dictionary where each key is a node_ID, and the value is the corresponding node details. Then, since my tree_search_result from the large language model is just a JSON string, I pass it into a Python dictionary with JSON.loads. Next, I print out the model's reasoning process by passing tree search result JSON into utils.printWrapped, which formats long text nicely so it's easier to read. After that, I loop through each node ID in tree search result JSON, take the matching node from my node map and print its ID, page number, and title, so I can clearly see which parts of the document the large language model thought were relevant to my query. Finally, I take the JSON string from tree search result and pass it again with JSON.loads, then take just the node list, which contains the IDs of relevant nodes. After that, I build a big string called relevant_content by joining together the text fields of each node in that list, separated by two new lines, so it reads cleanly. PageIndex is a new RAG mechanism. The AI explores documents as a table of contents tree, ensuring high relevance and providing clear evidence. It does not require a vector database, making it suitable for on-premise environments and for searching confidential documents. PageIndex is especially effective in fields where accuracy is critical, such as contracts, technology, and finance.